To our Better HVAC commissioning day here. This is Batu. He is my furry helper that provides a lot of shedding inspiration for our particulate monitoring here at ZOA. And today he is letting everyone know that he is representing the cause. So just give us a moment while we're finishing setup on our mic system. We'll be back in just a moment.
Go ahead and talk to me real quick.
All right, so we're here in the lab going over the badass HVAC system.
Okay, keep talking for me.
And we're going over the badass HVAC. No, I don't think so. We're just making sure everything's running right.
Hey, Jim, are we good to go?
Yeah.
So,
You ready? We live?
You're mic'd up.
Where do you hear me?
It sounds good. Let's go. Let's do this.
Okay, we're good. All right, I'll set this up.
All right.
Yeah, that's good.
Do you want that spun, Jim? I think you might want it the other way.
Well, let's do
There we go. You just tell me when we're
this
live.
format. We're live. We're live.
All right, so we're live.
There we are.
Oh.
All right, hey, Jim Bergman with measureQuick. Welcome to the measureQuick labs here. We're really happy to be here with a project we're doing with ZOA, General Air, IO Controls, and Bosch, and a handful of other people like Better HVAC and Nate Adams 2.0. And who else do we got here? Nate, come on in the screenshot for just a minute and say hello. So we got
Hello, everyone.
We've got a pretty interesting project we're doing here, and that is we're working with ZOA on a indoor air quality project, and it's really sort of a applied science project where we're getting to actually see how some of the filtering and how some of the indoor air quality aspects that we can control, how they actually work. So what we've got here, just to I guess start out here, is we built an entire system that's built around indoor air quality. And we've got 5 different air cleaners in it. We've got a 400D, which is a bypass HEPA filter. We've got a MAC 1400, which is just basically a general air cleaner with a HEPA or with a media air cleaner in it. A Terrace 1200 here, which is a media air cleaner with a UV light that's basically like generates hydroxyl radicals. And then we've got a media air cleaner. Now, obviously, we don't have all these in right now. We've just got in the Terrace 1200. We're trying to actually get rid of some of the smell of the fiberglass from the fiberglass insulation. This is all tied in with a Bosch heat pump, and the Bosch heat pump is running now. We're running about 0.2 of an inch of static, and we've got actually 2 different duct systems tied in with this. So what we're doing is actually design the duct system so that we could move the air out of the space and then back around to the filters. So we're working with what's called an entrainment model to try and get the air to move. We've also got tied into this a General Air DH75, which is a dehumidifier. So what we're doing on the dehumidifier is obviously pulling out the latent load. We're finding that, interestingly enough, even though the system is really sized well for the shoulders, it's a bit of a challenge to control the latent load in here all the time. And then Nate just got done tying in electric reheat in the air handler, so we can do electric reheat. So it's really tied around quite a few different things. We also brought in outdoor air, so we've got a duct that's about 80 foot long that goes back to the end here and ties in the outdoor air into the return air drop here. So basically what we're able to do is control the ventilation, the filtration, the dehumidification, the humidification, and all in this system. So there's a little bit of everything going on here.
Don't forget the havens we have in here too.
Yeah, and so the interesting thing is to measure all this stuff and to get it all going, we have the Haven air cleaners Haven air cleaners. My brain's a scatterbrain right now.
Central air
getting
monitors.
all the audio tied together and everything at the last second got me a little bit going here. So we're good. But we got 3 cams on there, central air monitors that we're tied in. And we have a cam, basically, we can't quite see up here in the return and supply. I've got one in the supply duct up here, got one back around in the return, and I've got another cam up in the
Fresh air.
Up in the fresh air. So we're actually watching the air quality coming in, which is quite interesting because we're here at TruTech, so every once in a while they get trucks come in, and we've actually seen some peak events already where we got some huge spikes in the CO2, and then we've also seen, obviously in here in the supply, we're getting to see how the filtering's working, and we're also getting to see, basically how our return air conditions are being controlled. And we just sort of got this thing started up yesterday, so we're just starting to get some good data off of it. But let me just walk you through a little bit in some detail, because I think some of these things are fairly interesting. We start out with just a standard filter. So what we're going to do in the whole experiment here is to look at, first of all, filtration. So we're in a warehouse area, TruTech tools, a lot of boxes, a lot of stuff coming in from everywhere in the world, from America to overseas. And so at night when we get close this warehouse up, 2 things happen. We get a lot of buildup of CO2, we get a huge rise in humidity, and then we get obviously during the day we get a lot of dust that goes around the shop. So this is what we've been using up to this point for our air cleaning in here. And so what we decided to do is this is our first set of filtration. So we're going to sort of baseline off this. And then what we've got up here is let me actually start up here. So after it comes out of that first filter, it's actually going into this, let me just make sure this is off here, into this general air filter. And what this has got in it is just a regular, what would you call this type of filter? Like a pre-filter?
Oh, it's a little media filter.
Yeah, just a media filter with a charcoal filter back behind it. So that's going to help remove odors. This is just a bypass configuration here. So what it's doing is, I can get this back in here. Come on. Up, there we go. All right. And then down below here is actually a HEPA filter. So this is a bypass, and what it's doing is taking a small amount of the air, that's coming in the duct. It just goes in the top. There's a fan that drives this through that's on a rheostat, and then it exhausts it back into the return air duct. So this is removing all the really small particles and also some odors and things like that through the charcoal. Then, down into the media air cleaner, these are standard MERV 11. And General does some stuff that's pretty interesting with their filters, is they actually gasket these, so they don't really have a lot of air bypass around the filter. And so after we baseline with a standard filter, then we're going to try the MERV 11. We'll look at the pressure drops through the filter. We'll look at how those remove the particulates. And then we've got the Terrace 1200. And this one's pretty interesting. Let me just pop this apart here. And here, Nate, you can be my beautiful assistant. All right, so this has got in here I believe it's a MERV. It was a MERV
11?
It's MERV 13.
13. Okay.
So this is a MERV 13 filter here, and it goes through this pre-filter, and then we go into this titanium dioxide coated screen. So it's basically UV light that hits a titanium dioxide coated screen, and then what this does is it makes hydroxide radicals, which are basically designed to kill viruses and bacteria and stuff like that.
And we get to see what it actually does.
And yeah, I think the thing that's going to be most curious is what it does to the VOCs in the space. All right, so we'll go ahead and pop that back on there. And then obviously, what we see a lot in our industry is just the standard media air cleaner. So we have the AC22 media air cleaner, and we'll get that in there, and we'll just compare all the different air cleaners together. So a lot of different filtration. Basically, there's a couple things that we can control on this. We can control we're looking at doing IAQ studies. What we want to do is control our filtration, our ventilation, our humidity. Yep.
Yeah.
You want to humidify, dehumidify, and obviously control our temperature. So that's what we're doing in this entire system. Now, the humidifier on this is a bypass humidifier. So it goes down here.
Dehumidifier.
This is a dehumidifier. Yes, thank you very much. I've been saying that all day because I've never owned one before. So everything in my life up to this point has been a humidifier. But now we're dehumidification.
That is my fault, Jim.
Yep. This is a really slick bypass humidifier. It's actually going into return. It goes around the back and it goes back into the return, back behind the air handler. And this thing, believe it or not, it seems like it's been running nonstop in this since we put it in. It really continually runs because we have a lot of humidity load in this building. And then we've also added in, over here, we got an IO controls, ventilation control. So this is basically opening up the outdoor air damper for so many minutes every hour and allowing us to bring in some fresh air into the building, which right now in Ohio, we're like at a 70-degree outdoor dew point, which is causing considerable load on the system. So it's really interesting as we're seeing things start to operate, things that are happening like that we didn't expect to see just from the get-go. Like when we have a huge rise in humidity, we're seeing a large rise in our total TVOCs. Yeah, in our TVOCs. And the reason we're seeing that is because when things get wet, they tend to outgas. So, we're trying to figure out just a balance between ventilation and filtration and, basically conditioning the air. So there's a lot of interesting data and some interesting challenges as we're going through this. Now, the Bosch air handler we have on this, what we did is this is a 2-ton air handler. We've got the fans actually set on low and medium low. And what we're doing here is we don't have a huge space in the back, but we wanted to keep this thing running as long as possible during the day. So we really have it optimized for dehumidification. And if you want to pull up the, I would have to go get the iPad for measureQuick. Can you, Eric, can you go over and flip that over to the capacities, where it says capacities? And so you'll see on there when you're looking at that, we're running some pretty interesting sensible latent splits on here. Last time I looked, it was about a 0.58 sensible latent split, meaning that 58% of the energy we're using is for cooling the air, and the balance of the energy we're using is for dehumidification. So we're pulling a lot of water right now on this system out here, and it's pretty common. We got a lot of textiles in here. We got all the ceiling tiles in here, so it's going to take a little bit of time to get this all dried out and running. So Bosch air handler on here, no filter in here. The evaporator coils down here in the bottom, blowers up here, electric strip heat. We have about a 3,000 kW heater here because we're on 208 volts. And we're tied over here to a Bosch heat pump system that's doing our air conditioning right now. So we have the inverter system is pretty darn slick. The way this thing is working is it's actually monitoring the suction pressure and controlling the inverter off suction pressure. So this is allowing us to really get really good dehumidification right now. In fact, we're looking, the Bosch unit's pulling out in about an hour what the dehumidifier pulls out in a day, because we have a huge amount of coil space on there. We got the airspeed set low, so we can do a lot of dehumidification really fast. The problem with just relying on the Bosch unit on its own for the humidity control is the fact that once it's evening and the warehouse cools off or the shop cools off, we don't have enough now sensible load to control our latent load. And that's been a little bit of a problem, even in my own home, where we actually need the dehumidification once we're past midnight. Because what's happening is once the Bosch system shuts off, we're seeing two things happening. One of them is this entire coil, evaporator coil, is saturated, it's wet, and the moisture evaporates off this coil and then basically reintroduces into the space. And then the second thing is there's just no sensible load for the system to start up again, so it'll be off for 5, 6, 7 hours, and we'll end up with a high humidity, and then we have to take all day again to pull that moisture out. So far it's been, what it's showing us is we have a lot of work to do. We have a lot of work to do to get this to actually control the way that we want to control the primarily what we're finding out is that the trickiest thing, I think, was you say, is humidity, wouldn't you?
Yep.
Overall, and we're finding out that the humidity at a get-go, at the first glance here, it seems like that's going to be the big driver for really controlling our indoor air quality. And I think probably also the big driver for the comfort in the office, because we've already seen, like just out here, it's a little bit more humid, and you can feel it's a little more oppressive out there. So the study that we're going to do over about the next year, and the duct systems are fairly interesting on this, because what we did, and the reason that it's going to take us so long to do this, is we have a couple things going on. We have both heating and we have both cooling we're trying to deal with, and looking at how we're going to control all those different variables. Now, we had to set this up with two duct systems, and part of the reason we did that is so we can blow air out across the room. And by the way, thank you, Michael Hausch, for designing this for us. It was a huge help getting everything sized. But basically, we have 4 8-inch supply runs out here, and these are all these round pipes here, and they blow straight across the room. They're going to carry the air across about 35 feet, hopefully entrain air behind it, so when the air is shooting out, it's going to roll back in and pull back into the returns. Then we also have this primary duct system that goes up and over, and that just goes to 2x2 lay-in grills that are up in the ceiling, just regular old ceiling grills. And so what we want to look at is, does it make any difference on which way we introduce the air into the room on how the particles return for the filtration? So a lot of interesting things going on there. Now, if you want, Ben, why don't you flip over for just a minute and show some of the data we're collecting off the Haven meters, because I think there's a lot of interesting things to look at right there. So what we're doing is, if you look at that, the data looks pretty crazy. There's a lot of zigzagging lines on there, and what you're looking at is all the cycles. And the Bosch unit, when you first start it up, it has to go through a little bit of a learning curve. So it takes probably a day or two for that to actually figure out how it wants to optimize the cycles for the best control. So Nate sat down today, we went through and programmed the thermostat and got all that tied in. So then we can do a couple of different things. Number one is multiple stages. These Bosch units are incredible if you set them up properly. If you don't, they don't work.
Not so good.
They're not so good. And the trick is with this unit is you need a 2-stage thermostat. And you need a 2-stage thermostat so that we get these cycles that it goes basically to the second stage, then ramps back to first stage, and up the second stage, ramps back to first stage. Because the inverter system, it doesn't respond right away and allows us to get that cold coil to wring water out of the system. Now, if you look at some of the graphs there, you're going to see, obviously, we also have a outdoor air damper on there, and you can see on the outdoor air where that is, and I'm hoping Ben's scrolling down a little bit so you guys can see that on the outdoor air, every time that opens, it opens up for a few minutes, introduces some fresh air into the room, and we'll be able to control the amount of ventilation into the space. So there's a lot of really cool things we're going to be able to tell, basically from the data we're doing about not only particles, which are interesting, but also just general system operation. And so, one of the things that I think more than anything I've learned just in literally a couple days looking at this is, if we were just to have turned the system on and just started up and walked away, we'd be doing a huge disservice to the customer base, because there is a tremendous amount of optimization that we can do to really get this thing up and humming, right? So I wanted Nate to just spend a couple seconds, explain, you and Michael, Eric, you guys sort of all came up with the
Yeah.
with a big ass drop, right?
Yep.
And so just sort of explain what you're doing there.
I brought this so I could actually remember all 6 things in the right order.
All right.
So HVAC 101 in this, there's 6 things that every HVAC system should be able to do. And Ben, if you can pull up slide 120 or 121, that'd be awesome. So every system needs to be able to do load matching. That's most important when it comes to comfort. Good filtration, I think we're probably covered.
I hope so.
Maybe just
Times
a little
5,
bit.
maybe.
Yeah.
Yeah.
Dehumidification, which this unit has the 824 Nexia thermostat with
Right.
IDS, which is the reheat dehumidification. You hear me talk a lot about that. This has it. So we have reheat and we have a dehumidifier.
Yeah, so that
we'll
should
play.
be interesting to see which one of those actually is more cost effective, because this dehumidifier does not use a lot of power. In fact, we were looking at that. It uses about half the power that even the Bosch system uses. And the cool thing with dehumidification is it's like actually engineered for that job. So it's going to run a colder coil and, maybe be able to pull out quite a bit of moisture, especially when we have the light load period. So
we'll see how it goes.
Yeah, and when you're running 3,000 watts of heat to reheat, I mean, you do get massive amounts of dehumidification, but you also get massive amounts of electrical
usage
at the same
but
time.
that has to run, like you said, this pulls in an hour.
Yeah,
but this pulls in a day.
Yep. So it'll be interesting to see.
Yeah,
how
I'm curious to see where it goes. So that's one of the experiments that's in here. We have everything. Fresh air. There's that nice 8-inch damper running all the way out, or 8-inch line. Right place at the right time, which is what I call mixing now. So if you have any rooms in a house that are different in temperature, if you stir it like a vinaigrette, you tend to blunt the temperature differences.
And that was a big reason for setting up the registers the way we did, is to try different air mixing.
And I didn't fully understand that until last night when we were talking.
Yeah, that makes a big difference. I mean, and also a big impact on human comfort, because just us standing in the room, where you're sitting, how the air is delivered. And this is also what's interesting with this, is because it's variable speed, we got 2 stages. The air, if it's coming out of the register, it can come out and fall down. It can blow all the way across the room. Same thing with the ceiling registers. It can either come out and mix, or it can just literally fall out. So it'll be interesting to see, comfort-wise, which one of these duct systems does 2 things. Number one, returns the particulates better, because I really, really think without good air entrainment, pulling it back, we're not going to get the particulates back. Because I'm
curious to see.
It's you can blow air across the room easy, but you cannot draw it back. It just fills the area low pressure. And then, obviously with the ceiling registers, I just don't know that that's going to create enough convective air currents to actually carry the dirt back
to get it
system.
over.
Yeah.
So we're going to find out. And the last thing, which is not on here yet, is the humidifier. So humidification, that's the last of the 6 functions.
Yep.
So what's kind of fun here, if you look at the diagram of Badass HVAC, this is the literal interpretation of it. So load matching is the heat pump. Filtration we've got here, dehumidification we have both in the system from the strips, and then we also have the dehumidifier. Fresh air line coming in. This unit's going to be mixing all the time.
Correct.
With either system, and then we'll have the humidifier on there. So between all of those things, normally you wouldn't have all this insane stuff going on, but it makes one relatively simple system.
I mean, I would glad to have all this going at my house, but
Yeah. Well, as general air, if you want to ship some stuff to Jim.
And the other interesting thing, that because we did put 2 damper systems on here, we actually, if you could pan up with a camera here for just a second, we do have 2 things here. IO Control got us balancing dampers up there, so we actually have a zone damper up top, and then right past that we have a balancing damper. And so what we're able to do here is basically shut off one duct system and turn on another at the flip of a switch. So that makes it really, really handy to do that. And then we're tied into if you want to pan back down here again, we're tied in here with the IO controls with a zone control board, and then down here with the ventilation. And then down below this is a really slick product. And this one is probably going to end up being way more useful than I ever imagined it would, because I didn't really realize what it was when they sent it. And this is a lodge watch. And we go out, we have a steel door here. We go in and out all the time. And right behind that steel door is where our filters are at. And Nate and I already saw this today. As soon as we opened up this door and had it open for any amount of time, our humidity just shot up, and particulates shot up, because we're pulling air from the shop. So what the Lodge Watch does is it's basically a magnetic door latch and it's radio controlled. So it's got a radio signal from the door back over to the Lodge Watch. And then when it sees that the door's been open for over 2 minutes, shuts it down. So it's a control that you would primarily see like used in rental properties, things like that, where you got, people moving in all their luggage, all their kids, all their stuff. They have the door open for 35, 40 minutes, and nobody wants to pay to heat and cool the outside. In our case, what it's doing, it's helping to mitigate some of the IAQ problems that we might have just simply from having the door open and pulling in the dirt and the dust and the humidity and everything else from the office. So, we have a lot of different things here that we're going to be able to try and, hopefully get the IAQ in the office to where I don't have to take allergy tablets anymore.
Can you introduce IO Controls and ask them to talk about their product?
Yeah, so if IO Controls would like to hop on, I'm not sure who we have on the... Megan? Oh, Megan and Kyle? All right, yeah, so I'd like to introduce Megan and Kyle. If you guys would like to come on and just tell us a little bit about what you guys do at IO Control, it's a perfect time.
Yeah, absolutely. Thank you so much for introducing us. So Kyle, he is our Midwest Territory Manager, and then I'm the National Sales Manager here at IO Controls. And we are a manufacturer of specialty controls, zoning, dampers, temp stats, fresh air ventilation, the ESP zone board and dampers that Jim has there on the measureQuick project. We are a part of that and have also provided that Lodge Watch as well as that fresh air ventilation kit. So once again, we're a manufacturer, and primarily we sell to wholesalers pretty much all over the entire United States.
Yeah.
It'll stay that way.
All right. So a couple other things I think are worth noting. Can you pan down here for just a minute? One of the things that this is sort of a telltale sign, on filtration, and I think it's worth pointing out here. We have this a trap on here, clear bottom on the trap, and the whole reason this is clear is because we want to make sure it stays clear. When you have dirt coming down, when it's bypassing your filters or you're not getting good filtration and it ends up on this coil, obviously the water rinses off the coil, rinses down the drain, and that's a good indicator that we're getting dirt in places we don't want it. So the clear trap on here is sort of a visual indicator for us that we have that we have clean condensate, right? Because condensate is distilled water, and if you've ever gone to the store and bought distilled water, you'll notice there's no dirt in it. But in our industry, you'll find all over that we see a ton of dirty condensate. We got a lot of condensate lines plugged. Huge opportunity for contractors to fix some of these problems on these air cleaners and things. And I think that the big reason we're doing this applied project here, and everybody goes, okay, this is interesting, but why are you guys really doing it? Well, at the end of the day, what we're trying to do is we're trying to, number one, identify the problem. Number two is try and implement a solution. And then we want to see if that solution works or not so that we can find out what actually works so that you don't have to do the experimentation yourselves. We're in an office here where if my indoor air quality is poor for a day, the only person that's got to suffer a little bit is me. You're in a place
Valerie
where
doesn't matter.
No, Valerie doesn't matter. No, Waffles though, he gets pretty cranky when he gets poor HVAC. So we do want to make sure that. Sorry about the noise in the background there. They're loading a truck of TruTech. We do want to make sure though that that as we go through and identify these issues, that we can help you guys provide good solutions. I'm going to plug my air cleaner back in. It's driving me crazy. I don't know. I have to have clean air in the office. But we want to make sure the solutions that we're telling you actually work. And there's things that, like I said, there's a lot of unintended consequences of trying to control things. And we're seeing some of those things right now. And it could be as simple as how we set up the heat pump, how we set up the airflow and the air handler, to what kind of filtering we use. We're real curious if these types of filters generate any ozone and what that's going to do to the particulates in the office. We're also going to be putting out some petri dishes so we can look at changes in the amount of bacteria in the air. So there's a lot of different things we're going to do, but we're trying to, this whole applied science project is about solving these problems for contractors so that you don't have to solve them on your own, so that when we look at something on the air quality meter and we can see the symptoms or see what's happening, that we can basically prescribe a solution that we know is going to work. So do we have anybody else need to come in the live stream, Val? Or Ben?
I might actually jump in for a bit. I don't know if you're able to hear me from there, you guys.
I was thinking about doing the same thing.
Anyways, for myself, yeah, I love the reason why us we make the Haven IAQ product, which is the these monitors that go inside of the ductwork. And we found that our product is great at detecting problems, but it's not. But solving problems is so difficult because of how diverse the problem is. And I love what Jim just said: is that there's unintended consequences that happen when you set up a system a certain way. And so this is a living lab. This is a opportunity for Jim, Nate, and anybody else to try something out and see what happens. So between all the tools that measureQuick is able to kind of, pull in as far as data during commissioning or data during problem solving exercise, and then Haven's long-term data that we're collecting, we believe that we're going to be able to uncover some really unique and interesting opportunities for pairing a certain type of reading or an outcome from an experiment with a solution that can properly solve the problem for the measureQuick office. And because we believe that to solve IAQ inside of a home, you have to make sure that better HVAC, or that HVAC is the thing that you are kind of solving with the right type of data and the right type of controls. And so between all the equipment that Jim is installing here and our and all the tools that we can pull data from, it's going to result in some really interesting insights for everyone to see. So we're going to be doing a whole bunch more of these live streams over the course of the next couple of months. I'm going to have other video content. If anybody has any questions or things that they want us to experiment with, then send kind of Jim or us at Haven a request to say that, hey, we want you to test light some candles, see what happens, or what happens when you vacuum. Let's look at all those readings like in the before and the after. So this type of data was never really available up until now, between kind of all the components that we're moving into this. And so I'm just really excited to kind of see what comes out of this with everyone involved. And we want to make sure everyone in the audience can also be involved in asking us questions or sending us requests.
All right. So anyway, well, we can go ahead. I just want to really thank General Air. General Air supplied us a ton of filtering so we could get this done. Shout out to Bosch for making a great product so far. We've been really excited to work with this air handler and the inverter unit. It's probably the only one I could have outside my office that runs this quiet. And then IO control helping us a lot with the dampering and all the zone dampers and all the balancing dampers so we can get this done. And then, obviously, Nate, thanks a lot for coming out and helping us get this thing set up. It's been an interesting experience because there is, like I said, we have so much flexibility here when how we're going to control this thing. The stat, you went over that stat a little bit. Can you talk a little bit about the Nexia stat and what that'll do for us?
Well, I haven't fully even dug into the thing yet, but in the initial stuff,
is it Tim Portman that told us to get this stat?
Well, Tim was the one that originally told me about it, and I've been talking about it for a while, but I haven't spent any substantial amount of time with one until today.
Okay.
So there's nothing like being thrown into the deep end with a 5-pound weight tied to your ankle. But I think I'm still treading water.
Yeah.
But that's been a nice stat, and it was interesting turning on the IDS. It's integrated dehumidification system, or might stand for something else.
That controls the electric reheat. And is it overcooling also, or just
it will let you overcool? Yep. So I set it for a degree of overcooling.
All right.
So that'll be a good thing. And so we're going to get to compare those two systems and see what happens. Because one thing so by all means we use dehus. So I have a 155 XT at my house here. But it's not an inexpensive piece of equipment, and it's probably not going to last the full lifespan of a piece of equipment. So you're going to buy two of them?
I don't know about that. I think this is going to work really well.
We're going to find out, aren't we?
Yeah, because
work that thing hard, Jim.
I think we will here. It hasn't shut off since I put it in, but I do think the filtering ahead of that, because we're pre-filtering. Yeah, I think a lot of times because people don't maintain these the way they should.
Yeah.
I think that's
filtration.
Filtration's the big one.
Nice one. Yeah.
And once that gets plugged up inside there, it's gonna flood the compressor. So I have just a gut feeling that this is a maintenance issue.
I hope you're right on that. I really do.
Yeah.
And that's one of the reasons too. I mean, this is the badass system. So it stands for Big Air Drop Air Source System. And it's important that you have one big filter ahead of everything, because then there's only one filter to change. And typically you can count on that getting changed once a year. At least they hopefully get a maintenance contract and get somebody in to change it out.
I think we're going to be probably 2 or 3 times a year in here pretty easily.
Oh, yeah. You might be more. But a media filter, if you let it go for a year, it probably won't break everything. Where if you use a crummy filter, it'll plug up pretty quick.
Yeah, the other thing I think that's interesting when just talking about a little bit on the installation here is the big drop into each one of these air cleaners. There are some important things when you're designing duct systems. You want to make sure that your transitions allow the air to have time to move out across the full media. We want to keep this air velocity somewhere between 250 and 300 feet per minute. It's ideal. If you get the air moving too fast through here, what happens is you get what's called sifting. So if you were to think about when you're a kid, you got a sifter and you were to fill it with sand, it really doesn't go anywhere until you start to move it. And when the air velocity gets too high, it does sort of the same thing. It just shoots those little molecules of dirt right through the filter. So, these are going to be really important that we have the air velocity at the right rate. Right now, I think these are running under 200 feet per minute for the most part, because we do have this dialed down pretty well so we can get the most dehumidification
what
out of
happens
it.
when you, because you just yesterday turned the velocity down quite a bit, right?
Yeah.
And what happened to the PM because of that?
The PM, we saw it dropped down quite a bit.
Yep. About at least 50%. So it's...
Yeah, so it is filtering better. And then the other thing that's, the big advantage here is we got, a really, really low total external static here. So we're running on, I think we're probably on, here, we'll take a peek here.
0.23.
Yeah.
And this should be on high because I turned it down to like 62 degrees, so it would run through the whole video.
Yeah, we're on Y2 right here. So this is sort of nice here too. We also get all the calls for heating and cooling. So we got the fan on. We are on the highest fan speed, and we're running 2.3 inches of static pressure, total external. So I got one tube down here in the bottom.
0.23, not 2.3.
Yeah, 0.23, yes, 0.23. That's what I said, didn't I say?
I thought you said 2.3.
I think I said
whatever.
0.23.
Somebody will tell us in the comments.
All right. So the total external static pressure being that low is going to really use, I think we're using about 60 watts of energy right now on the fan. And so, overall, this is a very economical to run. So, but if we got, do we have any questions on the live stream or anything, Ben? Any questions we can answer?
Well, just taking a look here. We got some people are adding some comments about looking for CO2. So that's something that here at ZOA we've been evaluating and prototyping some CO2 additions for a while. It's not a standard offering within our product yet, but it is in the works. So kind of looking at the kind of live dashboard here, we do have a couple of CO2 sensors in there that are kind of showing the levels as kind of the system is cycling through its different stages, and people are coming in and out, doors are opening and closing, starting to look at some of those trends. But CO2 is something that will be probably in the future, that'll be something that'll be a core part of the Haven platform.
Yeah, and Ben, if I can jump in as well here, we also you had mentioned when we're opening up the outdoor air damper, we're seeing a spike in CO2 because of the trucks running outside. One of the options that's available with our fresh air panel is the lockout terminals. Basically, any 24-volt signal that closes, the contact closes on that lockout terminal is going to force that damper close, and we're going to refuse fresh air. So basically, like I said, any 24-volt signal will activate that. So we can tie in pretty easily with that if that is an issue in the scenario that we're working with. Typically, residential situations, we're not seeing too many semi trucks running through and causing that issue, but something that is built into the panel there as an option.
Cool. So does that mean that you guys would be able to accept a 24-volt input signal that, like, let's say if Haven were to provide a 24-volt signal based on one of the readings that we have, you would be able to. Awesome. Well, then that's going to be something we're going to try in a different video, I think, because we've got these little central air controllers that we're introducing soon, which they have that 24-volt output based on our IAQ readings. So that'll be great to work with you guys on that.
Absolutely. Yeah, that works both ways. The lockout's going to force it close. Override's going to do the opposite. So we can do either way on that one.
Awesome.
Mm-hmm.
All right.
Waffles.
So, any other questions we can answer?
I have one other thought.
Yes.
So one thing that I thought was genius on your part was when we first talked about this, we were basically just going to use it to play around with the air out here in the warehouse. And then you were like, but it's not really an experiment if we don't actually experiment on a space.
Yeah, we have to have a control variable. Yeah. All we do out here is just detect we got a lot of dirt and VOCs. And that was a big thing. So we actually, as part of this project, we actually completely isolated our office space from TruTech Tools office space. So we actually removed the entire duct system. We actually had a company out, a local company called Eccles Heating and Cooling. So Eccles came out and they did all the sheet metal for us and did all the ductwork installation. And so it started with a removal of our existing system and tying it back in so TruTech could get all that cooling over there, and then all new ducts and two new duct systems in our offices here, which Waffles liked a lot, didn't you, buddy? Huh? Yeah, he had a good time playing ball with everybody that came here. That's his thing to do. But it's going to allow us, because now we can actually not only see how it impacts obviously the office space, but how it impacts us personally. Because I think that was one of the big challenges we had. Is every time I come to work, eyes are burning, my throat's sore. It's tiring being in a space with, and we have no ventilation really in here. Yeah. So these are flex spaces that are sort of built, around warehouse space. They're really not designed for keeping everybody cool and comfortable and happy and healthy. So for us, it was a really good opportunity to, I think, throw the human element in there also and just see what we can do to make ourselves more comfortable.
We're going to try and save Jim.
Yes. Yeah, that's a good idea. So, but, well, Ben, did you have anything else we want to say before we wrap this guy up?
Yeah, we had a couple of questions about, because I have a couple of times shown off the Grafana dashboard. And what this is, just for anybody that's kind of watching here, ZOA has a beta program. And we have our pro portal. So like for anybody who's a customer, a professional would be able to remotely view their customers' data through our pro.haveniq.com, where we kind of have made a custom interface that includes a bunch of information about the customer's home. It's just taking a second here because it's loading lots of different accounts that are loaded into our system. But let me just grab my home here. So this is what we've created for the typical company that would be viewing our data remotely. And so it allows you to be able to do comparisons between your, let's say, two different measurements at once, whether it's VOCs, relative humidity, temperature, or PM. It's got a couple of overlay options to be able to understand whether the HVAC fan is running or not, a little bit of analytics. And then we're introducing some really interesting features that allows you to visualize the equipment that is all wired up in the home. So some of that is still in prototype, and we'll be releasing it soon. But what you see here in the Grafana dashboard is anybody who's in our beta program gets access to working with me to visualize the data however that they want to see it. And so if anybody wants to join the Haven IAQ beta program, you can just email us at prosupport@haveniq.com or probeta@haveniq.com. And we'll be able to, see if testing a device or a couple of devices is something that we can work together on. Because really, what Jim is showing off here is kind of like a super advanced iteration of our beta testing, where we get to unlock some really cool stuff underneath the hood that might not always be available to the public customer, just because this helps us understand what the market really wants, and we want to work with those type of people that are super excited to play with this data and to prove out some cool solutions. So.
All right. So yeah, I mean, this has been. I think one more thing I'd like to just say in closing here is, a big reason we actually got involved with all this with ZOA, with General, with IO, with this entire project was because, when Ben, actually, I think Nate called me and he said, hey, there's a company called ZOA. They got a product called Haven. You really ought to take a look at this thing. And, so I had one sent to my house. And this is like during COVID. And so I'm sitting around. I have absolutely nothing to do. I'm looking at, we're working on software, obviously, busy all the time. But it's, I had a few minutes, and it literally takes about 15, 20 minutes to install a Haven into your house. So, it's an 1.5 inch hole in the ductwork. You slip it up in, 24 volts to it, and literally it starts monitoring. And immediately I got to see how poor my indoor air quality was, particularly on the particulate side. I had a lot of particulates that I just didn't realize were floating around the house. And then I really realized, it is a little dusty in here. And so I actually just went down and I bought some, I measured up a new return, added another return in the basement, and I literally cut the dust in my house in half. And it was, literally overnight.
Was that a bad?
It was pretty good. Yeah.
Well, that was a big airdrop you put in there. You put double filters instead of one.
Double. Yeah. I had about 700 feet per minute of filter face velocity, and I dropped it down to under 300 feet per minute. And that on its own made probably the biggest improvement in the air quality of my house. And had I not put a Haven in there just to measure it, I would have never known. And that's the problem with our industry is we try and implement solutions like, this all the time, but we don't really have an opportunity to test in, test out, see the impact.
Well, we look at a component. I mean, what we do is very similar to medicine for houses. And like doctors, I was just reading the checklist manifesto, and there was this wonderful line in it that said that as doctors, we focus on having really good individual components, but we utterly ignore how the components fit together, so the result sucks. And the only reason to understand what the best practices are this sort of thing. And I want to give a big plug to Ben and Zoa and the rest of the team, because anyone who knows me, I dug deep into the consumer-grade air quality monitors back in 2016. So I wrote kind of the first truly comparative thing. And then like some of the national labs were following some of the stuff that we did. And I only wanted a few things out of an air quality monitor. I wanted to have decent readings of PM, TVOC, temperature, and humidity. I wanted decent readings there and a dashboard that I could look at multiple clients at the same time. And there was only one that really passed that test, which was Fubot, and then they pulled off the market. And so hands down, my favorite is the ZOA Haven, having looked at pretty much everything. There's a few other ones that are still useful, but this is a really nice product.
Yeah, and I think the other big thing for me on it was just being able to see, like when I put in this inverter system in my house, how it was interfacing with the house, because we had these 19-hour run cycles now, and what was crazy is when it shut off, I'd see my relative humidity would go down because my temperature was going up, but my dew point was climbing the entire time. Yeah. So just being able to see some of these relationships and how the house interacted with the equipment. ZOA is way more than just a particulate meter. I mean, it's really looking at the entire system operation. I think
particulate meter though.
What we're going to find is over time is that if contractors, install a new system for Mrs. Jones, install a Haven at the same time, do an indoor air quality study for a month to a year, they're going to find additional opportunities for selling, better filtration, better ventilation, zoning, whatever, there's a lot of different solutions that are going to provide a lot of. And
you're going to get confident in selling all these. Yep. I mean, so for years, one of the first projects I helped out with that got a heat pump in it, I told the guy, all right, I want at least a 2-stage. Like, nah, you don't need that. And he shows up, I got you a 1-stage, and it's a size bigger than you wanted. I'm like, son of a, that's exactly what I didn't want.
Yeah.
Because he didn't understand what it was. But as you start to measure things and watch your projects, you get much more confidence that this stuff works. I mean, Badass HVAC came out of me watching 40 air quality monitors in a bunch of different client homes.
Yeah.
And if you don't have the right things, I mean, right size variable speed equipment is critical to solving all these, because you want to be adding a little heater, a little cool as you're doing all of it. You want to dehumidify as much as you can with the system, not having to lean on other pieces.
Yeah, and I think that's the big thing we're doing, because you and I don't mind watching grass grow and looking at data. It's just going to be taking this stuff and helping contractors make better decisions. So
exactly, and sell better stuff for better margins.
yeah, that's big. Yeah. All right. Well, thank you all for coming out to the measureQuick Labs. If you have any questions or comments, or you have any suggestions on how we can improve this system, things you'd like to see us test on this system, anything that you'd like added or removed from the system at some point so we can try something else, please feel free to reach out to us. This is probably going to take us over the next year, maybe the next 2 years, to actually look at all the different things, because we want to go through heating seasons, we want to go through cooling seasons, we want to look at
shoulder seasons.
Shoulder seasons, which
those
is
are the
what
hardest.
We're in now. Those are the hardest to control. Yeah, I agree with that. And see what we can do to make all of our industry better. And what's sad is this is all stuff I think we forgot. It's what it's just showing 1922.
And 1922
carrier book
thing
today, and on temperature and humidity, and it's like it's amazing as an industry that what we knew and what we forgot. So hopefully we'll learn back a little of that knowledge.
What is Brian's line on that? To help you learn some new things, remember some things you never learnned in the first place.
Never learned in the first place, I might have forgot. Yeah, something like that. All right. Well, thanks a lot for attending. And Ben, you want any closing words?
Sure. And it's just to kind of bring it all home on what better HVAC is. It's not. We just use the hashtag better HVAC when we're generating content to just get some attention for this project. But if anybody that's watching, if you make content, if you post on YouTube, Instagram, TikTok, or wherever else you want to put your content, if you believe that you're doing something to make the industry better, that you are always striving to solve problems better, to use data to find a better solution for your customers, that's better HVAC. For me, I believe that there are some huge opportunity to see a kind of a change from the status quo, because like even what Jim and Nate just said, there's a lot of stuff that we've forgotten, but there's also a lot of stuff that until we've had access to this type of data, it was never possible to be able to do these types of things. The control systems that we have access to now, for us, like we've spent years optimizing our hardware production to make sure that we can kind of hit a combination of high quality readings, high quality controls, reliable kind of wireless connectivity that a decade ago it wouldn't have been possible because the technology wouldn't have existed. So we're really excited to just try to use this whole better HVAC idea to bring this all together, to demonstrate that it is possible to do things better, to and do it faster. Because with the state of the world, with this summer is going to probably be one of the worst forest fire seasons we've seen in a very long time, because of especially on the West Coast here where we are. Did a road trip this last weekend where I almost got caught between a couple of forest fires on my road trip. They were about 1 kilometer away from where I was driving. Had to wear kind of my N95 mask outside because of how dense the smoke was here in northern BC. So air quality and HVAC are so intimately linked together, and you can't solve air quality problems without first solving HVAC problems. And so that's what we're here for. That's what everybody in this project is excited to do. So, like Jim said, this is going to be could be a year or two of this journey, but the whole thing is just going to be continuous learning. So I'm super excited to be a part of this and for everybody else to be here.
Well, thank you then. I guess we're signing off.
We're signing off.
See you everybody next time.
Thank you. Thanks for having us. We appreciate it.